Study section 10. Uses of the truth table. Study section 10. Uses of the truth table. Introduction. In this study section, we will be exploring how to use truth table to show statements that are tautologous, contradictory, or contingent. We will also use truth table to show the pairs of statements that are logically equivalent. Learning outcomes. When you have studied this section, you should be able to discuss the meaning of truth table, distinguish a tautologous statement from a contradictory or contingent statement, use the truth table to work out which pairs of statements are logically equivalent. The meaning of truth table. A truth table is a table containing an array of T's and F's in columns and rows. The number of columns a table should have is a function of the type of compound statement under consideration, while the number of rows is determined by the number of simple statements that make up the compound statements. For instance, where you have two simple statements forming a compound statement, the number of rows will be 4, whereas if the statements are 3, the number of rows will be 8. Our simple explanation for this formula is this: every statement can only have 2 possible values. It is either a statement is true or it is false. To determine the number of rows a truth table should have for a particular expression, we count the number of simple statements in that expression and then raise 2 representing the possible values to that number. Where you have 2 simple statements, it will be 2 raised to the power 2, which is 2 times 2 equal 4. It means for any compound statement having 2 simple statements, the truth table will have 4 rows. Where you have 3 simple statements, it will be 2 raised to the power 3, which is 2 times 2 times 2 equals 8. And where you have 4 or 5 simple statements, it will be 2 raised to the power 4, which is 2 times 2 times 2 times 2 equals 16, or 2 raised to the power 5, which is 2 times 2 times 2 times 2 times 2 equals 32 respectively. Each row in a truth table stands for a possible word of interpreting the statement or argument as the case may be. In allocating values to statements in the truth table, it is advisable to start with T, that is capital T, instead of capital F. This is, however, a matter of convention, as one will still arrive at the same result if one starts with capital F. The most important thing is to be consistent. The allocation must be done in such a way that the first simple statement will share the 2 values in equal proportion in all the rows. For instance, where we have 3 statements which will give us 8 rows, the first statement we have 4 T's in the first 4 rows and 4 F's in the last 4 rows. The second statement we have 2 T's in the first 2 rows, 2 F's in the next 2 rows, 2 T's in the 5th and 6th rows, and 2 F's in the last 2 rows. The third and last statement will have T in the first row, F in the second row and continue in that order until it gets to the last row. In fact, in the allocation of values to statements in a truth table, the last statement must end with T in the first row. In the second In fact, in the allocation of values to statements in a truth table, the last statement must end with capital T in the first row, capital F in the second row, and must continue in that order until it gets to the last row of the table. Let us now learn how to use the table to show statements that are tautologous, contradictory, or contingent. Tautology, contradiction, and contingent truth. A statement that is true under all interpretations or in all possible words is called a tautology. When it is false under all interpretations, it is contradictory. A statement is contingent when it is neither tautologous nor contradictory. Such a statement will be true in some rows and false in some others. In the final interpretation of statements as tautologous, contradictory, or contingent, we check the values in all the rows under the column for the major logical connective for that expression. Let us now work out the following statements to see which of them is tautologous, contradictory, or contingent. Number 1. P or not P. True, truth, false, truth. False, truth, truth, false. This statement is tautologous. Number 2. P and not P. True, false, false, truth. False, false, truth, false. This statement is contradictory. Number 3. P or Q. True, truth, truth. Truth, truth, false. False, truth, truth. False, false, false. This statement is contingent. Number 4. Parenthesis open, bracket open, P then Q, bracket closed, then P, parenthesis closed, then P. Truth, 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 truth. Truth, false, false, truth, 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 truth. False, truth, truth, false, false, truth, false. False, truth, false, 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 truth, false. This statement is tautologous. Number 5. Bracket open, not P and Q, bracket closed, not okay. Number 5. Bracket open, not P and Q, bracket closed, and bracket open, Q, then P, bracket closed. False, truth, false, truth, false, truth, truth, truth. False, truth, false, 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 truth, 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 false, truth, truth, false, truth, false, false, truth, false, 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 truth, false. This statement is contradictory. Logical equivalence. When two statements are logically equivalent, it means they have the same logical force or have the same truth value, and so can easily replace one another. Put differently, two statements are said to be logically equivalent when they are either both true or they are both false. The sign for logical equivalence is the same sign used for the biconditional, that is, the triple bar, to rest if two statements are logically equivalent. We join the two statements together with the biconditional sign before working out the truth table. For two statements to be logically equivalent, we check the values in all the rows under the column for the major logical connective, this time the triple bar for that expression. If all the values are true, then both statements are logically equivalent, otherwise they are not. Following this explanation, we can agree with capital A Following this explanation, we can agree with capital A, capital G, capital A below that if two statements are expressed as a biconditional, then if the resulting expression is a tautology, then the two statements are logically equivalent. Below 2000. Let us now use the truth table to work out which of the following pairs of statements are logically equivalent. Number 1. Bracket open, not P, then not Q, bracket closed, and bracket open, P or not Q, bracket closed. To test whether or not the two statements are logically equivalent, we write out the two statements as a biconditional thus. Bracket open, not P, then not Q, bracket closed. If and only if, bracket open, P or not Q, bracket closed. False, truth, 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 false, truth, 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 false, truth. False, truth, truth, false, truth, 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 false. True, false, false, true, false, true, false, 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 truth. True, false, true, false, true, true, false, true, true, false. The two statements are logically equivalent. Number 2. Bracket open, P, then Q, bracket closed, and bracket open, not P, then not Q, bracket closed. Bracket open, P, then Q, bracket close, if and only if, bracket open, not P, then not Q, bracket closed. True, 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 truth, false, true, true, false, truth. True, false, 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 true, 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 false. False, true, true, false, true, false, 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 true. false, true, false, true, true, false, true, true, false. The two statements are not logically equivalent. Study section summary. In this study section, you learn that a truth table is a table containing an array of T's and F's in columns and rows. The number of columns a table should have is a function of the type of compound statement under consideration, while the number of rows is determined by the number of simple statements that make up the compound statement. There are many uses of the truth table. The truth table can be used to exhibit the truth conditions of logical connectives. It can be used to characterize statements as tautologous, contradictory, or contingent. It can also be used to show pairs of statements that are logically equivalent. A statement that is true in all possible words is called a tautology, while a statement that is false in all possible words is said to be contradictory. A statement is contingent when it is neither tautologous nor contradictory. This is the end of the section 10. Thank you for listening.